Thursday, November 13th, and we are on day 24 of Algebra 2. And we are looking at these 4 problems I gave you for the do now. Now, these are tricky. So, let's start with number 1. I have a 5 and a 5. Both of my bases are 5. 5 to the negative 2x power equals 5 to the 3x power. So, as you guys were looking at this, did any of you figure out what might be a good first step to solving for x here?
Actually, your bases.
Yes. So, thinking back to yesterday.
1 and 2's checked off.
Yeah, the very first thing you want to do is figure out what are my bases. And in this case, they're both 5. If the bases don't match, we want to make them match. But these already match. So when the bases match, they cancel out. Matching bases cancel. So I'm going to write that. Matching bases cancel. Once we've canceled our matching bases, what should we do with the leftover exponents?
Bring them down.
Bring them down. We're going to take them out of the exponent spot and make them into their own equation. So I'm going to rewrite negative 2x equals 3x. So what do I do now? This is as far as we got. Did anybody get farther than this?
No.
Get a little stuck on it? This one's tricky. It actually, as I was looking at it, I wasn't sure what to do at first either. Because what's your first thought of what to do?
Find the one.
Well, now we don't have exponents. This is just like a regular equation. How would you solve this?
I was thinking multiply the negative 2 and the 3.
Multiply the negative 2 and the 3?
Yeah, because they both had an x. That's why I was thinking about that.
So what do you mean multiply the negative 2 and the 3? Like
Distribute to make it negative 6x.
Can't do that because there's an equal sign.
Yeah, so here's what we've got going on. It's like we have, remember there's a line to our equal sign. We have 2 sides of our equation. I'm trying to figure out what number can I replace x with that whenever this number is here.
1.
Ooh, 2 and
Subtract 3.
Subtract
Side.
3. Okay, subtract 3x or 3.
3.
Can I
3.
take that 3 off of there? Because this means 3 times x. And this means negative 2 times x. These are terms. They can't be separated by subtraction. So keep the x. Okay, so let's bring down the x. So I'm going to subtract 3x over here. I'll subtract 3x over here. I shouldn't have written that. Right here. So negative 2x minus 3x. What is that?
Negative 5.
Negative 5x. So I have negative 5x. I'll bring down my equal sign. What is 3x minus 3x?
0.
0. Oh. We technically, in a normal equation, when there's something left over, like maybe it was 3x plus 1, for example, we would say those cancel. We bring down that 1, but the reason we're not going to say these cancel is because really, when something cancels, it's because it's adding up to 0, and we don't have to write 0. But since there's nothing left over here, we are going to write 0. Does that make sense? We need to write 0 because 3x minus 3x is 0. If I start with 3x's, I take 3x's away, I'm left with nothing, which is 0.
You have to have something on.
Yeah, and you gotta have something on both sides of your equation. You gotta have something. So if we want, we could still cross it off and just say, that's where that 0 came from, okay? I'm still trying to solve for x, though.
Did you divide both sides by negative 5?
Yes. Now we can divide by -5 on both sides. And those 5's cancel. We'll be left with x equals 0. 0. 0 is scary, but it exists. We can use 0. We can double check that this is correct because whenever I plug in 0 for x, -2 times 0 is what?
0.
0. 3 times 0 is what?
0.
So is 0 equal to 0?
Yep.
Yeah, so it works. It works. 0 is a strange number.
I feel smart now.
Yeah. Yeah.
Oh boy.
Got it. X is 0 for number 1.
Now, number
Good.
2, okay, do that.
Oh, Bubba.
Okay, so now that we've seen the process for number 1, I bet number 2 is going to be easier.
Yeah.
So tell me, what should we do for number 2?
Cancel out that
Cancel out.
stinking 3.
Yeah, cancel that stinking break. Come on.
Yeah.
And then what?
You bring down 2x equals x plus 5.
Yes, I'm going to bring down. I am going to bring it over, actually.
This one's
All
a
the
bit
way
easier
over.
because there's 2.
That's a lot.
So 2x equals x plus 5.
You draw your line.
I'm going to draw my line,
Yeah, subtract 2 on both sides.
subtract the 2x.
That's what I did.
Okay, you could do that. We'd be left with 0 over here equals x minus 2. We'll get a -1x. If we're trying to get our x's together, I'm going to always recommend let's get rid of the smaller x first because then we don't get a negative x. But you can still do -2x. You could do that. I want to do it the other way. Is that okay?
I did.
Which one you want to do?
You did -2x also?
No, I did.
I'll show both ways. Because we can do it both ways. So I'll do the -2x first. So we subtract 2x from both sides, and then what happens?
Oh, I did my 2 on the 5. Not that.
Oh, but can you
Oh,
do
I see
that?
what I did.
Ah, yeah, because this is 2x, 2 times x.
Oh,
He's so
boy.
stupid.
Okay, so how about this? How about I put a 1 in front of this x,
Yes.
and I
Oh,
just
that's
pretend
hilarious.
that I subtracted 1x. I'll turn that into a 1.
Okay, so turn it into a 1.
Okay, so I'm subtracting 1x. What happens to my 1x's?
Like, cross out.
They cross out, they cancel. 2x minus 1x is?
1x.
Yeah, it's 1x. Or we could just write x equals, what comes down?
5.
5. That's it. That's your answer.
Oh my.
Oh.
That's not so bad.
See, I was 2 numbers off. I got 3.
That's okay. Today might be a good day to go over some of our just equations, solving equations, just to make sure we remember all the rules. Because, you know, we haven't done a lot of equations lately. We've been doing graphs. Okay, so for number 2, we got x equals 5. Do we have any questions on that one?
No.
No? Okay. Okay. So the first 2 problems, we had matching bases. We were able to cancel our bases. But for number 3, that is not the case.
Dang.
So, what do we need to do?
Hold on.
Number 3, I got you on that.
Yeah. Took me a minute, but it's fine.
We just have to find out what the exponent is.
Mm-hmm.
Allow this.
So it's asking you 3 to the what power is equal to 531,441. It's a big number. So what are you trying right now, Diane?
Okay. You have 2x equals 1x plus 5.
Yes.
Then
Oh, are
you
you
put-
looking at
is
number
that a
2?
subtract 1? That is a -1 or subtracted by 1x? Is that a
Yes.
subtraction?
Right
Yeah.
here, we subtracted 1x from both sides.
Right,
And that canceled my 1x's.
right,
And then I did 2x minus 1x, with that left us with just 1x left.
right.
And then we brought down the 5 and it solved it. That was all we had.
So I didn't have to use the 1x, just the x. So I'd have to bring that one
I just put a 1 in front because I
No,
accidentally
I'm
wrote
still
2.
stuck on the other side because that one.
If there's one, if it equals out to 1x, you don't have to write 1x. You
Okay.
just put an X.
Oh, you're okay.
Yes.
Okay,
That's what had
good.
me
So
too.
you
Yeah.
got it. That makes
Yes.
sense. Good.
Yeah,
Yeah,
if it's
so
just,
on
if
that
it's
one-
just 1x, you don't have to break down the 1.
Yes, the
So
1
she's
is
So it would be like a
one.
0 then.
Right.
Yes.
So you would still just,
Yes.
you're basically just still bringing down that x from the top.
Yeah, you're doing minus x, minus x. We just put a
Gotcha.
1 in there to help us think about the number that it would be. Okay. Okay.
Gotcha.
Good. I appreciate you asking that. I would rather us go back and make sure we get it than to stay confused.
So do I
Always.
cross that out?
Uh-huh.
Do you cross the 2 and the 1, the 2x and the 1x out? We just leave as is?
We leave it as is because they don't cancel. We're just subtracting that 2x. We take 1x away. We're left with just 1x after.
Oh, like that in the play.
Yeah, I was done with it.
Are we ready to work out number 3?
You write 3x equals, or
Whoa.
3 to the x power
Yeah.
equals 3 to the 12th power.
Ooh, okay, so we don't have matching bases here, so that's what you're doing, right?
Yeah.
Trying to get the bases to match. So we're trying to see how can I write this number with 3 as a base. So 3 to the what power gives me this number. And that's what we're figuring out. This is where we go through and type in 3 to the, I don't know, it's a big number. Maybe we start with to the 6th power. That doesn't work. To the 7th power. That doesn't work. To the 8th power. And that's when we eventually get up to what Amber said. 3 up arrow. And we type in, she found out that 12 worked. Yeah. When you do 3 to the 12th power, you get that number. So I can replace 531,441 with 3 to the 12th power because they are the same. Okay, so I'm going to write that here. These are equal. So we're going to cross this out and bring down 3 to the x power equals, what am I writing instead?
3 to the 12th power.
3 to the 12th power.
Your bases are the same.
Yep, and now they're the same. Go ahead.
So then,
Now that both bases are 3, they cancel, and we bring
equals
down.
12.
Good. X equals 12.
Can we just keep all of them so simple like that?
If only. If only.
I found that one quick. I'm like, bet.
Yes.
The other ones was
So
like-
I thought that was, is the brackets the absolute value, right?
Brackets, absolute value, like the up and down, yes.
Yeah, I thought I saw that as 53 absolute value.
No.
So I worked it out like that, and I was like, I can't find the.
Oh, I'm sorry. Oh no, yeah, these are ones, not absolute value bars. Yeah, anytime that I give you absolute value bars, I'll try to make it super, super obvious. I'll make them really tall. Darn it. Okay, well now that we know it's not absolute value, does it make sense how we got that?
Yeah.
Okay, good. Good. Awesome. Okay, before we go to the last one, I want to make sure, does anybody have any other questions about number 1 to 3? We feel good about them? Okay. Okay, so let's look at number 4. What is the base on the first side of my equation?
3.
It's 3. What about the other side?
27.
27. So the bases don't match. What do I need to do?
3 to the 3rd power equals 27.
Ah, okay. Since the bases don't match, we need to replace 27 with 3 to the whatever power makes it 27. And you said 3 to the 3rd power equals 27. So let's replace 27 with 3 to the 3rd power.
What do you do with the x?
What do you do with the x minus 2?
You bring it.
You bring it down.
Bring it down into the exponent. We want to bring it down, but it's an exponent, so we want to keep it an exponent. There's a 3 there already, so we just put it beside the 3 in parentheses. So we're bringing down the x minus 2, and we're still going to bring down the rest of the equation. So what else comes down?
3 to the third power.
Yes. 3 to the 3x power. Okay, so now I have 3 to the 3x power equals 3 to the third power times x minus 2. I might not be saying that properly. I need to figure out how to.
So your bases match, so you cancel them out.
Yes, okay, so let's do that. That's the next step. Our bases match. So we can cancel those 3's that are bases. And then what?
Bring down your 3x equals 3. Parentheses x minus 2, and then you.
Ah. Okay. So I brought down my exponents. Now what?
You distribute.
Distribute.
See, look, couldn't figure it out before.
Yes. So now what?
Add a 1 in front of your x and then parentheses.
Yeah, well, you can put a 1 there if that makes it a little easier to think about. So I've got 3 times 1x is 3x. And then 3 times minus 2, -6. Okay, so I'm done with that. What happens now?
Bring
Still.
down your equal sign.
Yeah, let's bring down 3x equals 3x minus 6. Something's going to happen with this problem. Do we have all of our like terms combined?
No.
No. So what should I do?
Add 6.
If I add 6 to both sides, it will cancel it here, and then I'll just have 3x plus 6 equals 3x.
Subtract 3.
Okay, so I need to get my x's together.
Yeah. So you need to wait.
So we can
minus
subtract the 3x. Mm-hmm. Okay, and what happens? This one's funny.
Both equal 0.
They both
Yes,
equal 0. Because 3x minus 3x is 0. I'll bring down my equal sign. I don't have to write 0 because I have a -6 I can bring down. I could still write 0 minus 6. That would be fine. But I'm going to say it cancels. I'll bring down that -6. And now I don't have any x, I don't have any x. What does this mean? No real solution. There's no solution to this problem. This is not true. No solution. That happens sometimes. It happens sometimes.
That's crazy too. Make you go through all that.
I know. But no solution is an answer.
Right.
Because you have to get through to here to be able to confirm, yeah, there really is no number that works.
Well, no wonder why we couldn't figure it out.
That's good. It's good.
That's not his.
All right.
That's right.
So now you guys know what to do when you've got all kinds of extra crazy stuff in the exponent. Let me give you guys a few things after this. I'm gonna pause this recording.
I think we should take some notes on the no solution.
Yes,
Mm-hmm.
we can absolutely do that. So I'm going to. That was rough. Pause. All right, so I'm going to pull out this do now, and let's start by taking notes on solving equations. We'll keep the exponent stuff in there though, because it's gonna mix in with it. So here is, we'll call this algebra 2. And I'll title this as our day 24 notes. And take one. Thursday, November 13th. Solving equations. Okay, so whenever we are solving equations, the absolute most basic first thing that we talk about is something called inverse operations. Do you guys remember ever learning about inverse operations? Maybe. So this is what we're gonna write. Inverse. Do we know what inverse means? Or can we guess?
Well, there's reverse and then there's inverse.
Reverse, inverse. Hmm.
Something.
So the inverse of something is like the opposite. The opposite. So I will underline this and write above inverse. Basically just means opposite. So there are a couple of things that we talk about when it comes to inverse operations or opposite operations. So whenever we see, for example, addition, we see a plus sign. What's the opposite of addition? Subtraction.
Oh, yeah.
Yeah, the operations are just the things we do to the numbers. So we know the opposite of addition is subtraction. The next thing we have is our multiplication. What's the opposite of that?
Division.
Yeah, division. Good. And so let's also talk about what we may see these operations look like in an equation. So I'm going to write over here MULT just for multiply, and then abbreviate subtraction with sub, and then abbreviate division here. So these are kind of the four main operations that we're typically looking at when we solve an equation. And the two that can get tricky to figure out what is happening, I think sometimes are the multiplication and the division. Because whenever we have, for example, I'm going to pull an arrow out and write examples of multiplication. Just started back up.
Oh, my.
So we're talking about inverse operations, the opposite in equations. So adding, opposite is subtracting, multiplying, opposite is dividing. And so we see multiplication in different ways. For example, if I have 2x, what does that mean?
2 times X.
2 times x. Yes, yes. I'm gonna write here 2 times. What if I had 2 in parentheses outside of x plus 3?
2 times X plus 3.
Yeah, it's just 2 times that x plus 3. So really it's 2 times x plus 2 times 3. Because we're distributing. So distributing is like multiplying multiple times. This would be 2 times x plus 3. And that's happening. We're going to write distribute. So that's where we draw those arrows. We multiply by both things in the parentheses. Okay. And so if we have problems like this, for example, where I have a 2x in a problem and I'm trying to get rid of the 2 to get x by itself, we know that this means 2 times x, so we can use the opposite division. We would divide by 2 to get x by itself in a problem. Or in a problem like this, if we cannot distribute, we can use division to get rid of the 2 because this is still multiplication. So these I think you guys are pretty familiar with by this point.
So, I think we should do that with just like
Somewhere.
So, I think I should write that out. So you saying 2 times X like 2 times X. So 2 times 2, right?
So
Right, 2 times, right?
So it would just be 2 times whatever number x is. We don't know what x is.
Oh, okay.
It's like saying I have x plus x.
So if it was a number over there,
Yes, if there was a number
Oh, okay.
for that x, like if x was 3, it would mean 2 times 3. But we're going to say 2 times x because we don't know what x is.
so okay. So then at
Yes.
the bottom it says 2 times X plus 3. So whatever that X is inside the parentheses, you know that you would do like if the 1, 2 times 1
Yep.
plus 3.
Plus the 2 times 3, right?
2 times, so you're right, 2 times 1, which would be 2,
Uh-huh.
plus 2 times 3, which would be 6.
Yes.
And then you would add both of them together.
Yes. You would. You got it. You got it. Absolutely. Okay. And division, I'm going to make an example of that as well. The only thing that I think can get mixed up with division is when we see it as a fraction. So I'm going to write EX. Example of division. Let's say I have X over 4. What does this mean?
It has to be a number with an X at.
Yes, there will be a number eventually where X is.
You divide.
But what operation is happening here? Division. It's just X divided by 4. So if I wanted to get rid of something like this, we use that opposite and we multiply by 4. That would get rid of this 4 that's being divided. So we can say X divided by I spell divided.
You got it right, but it's ED.
X divided by
It's
4.
one of them that like everything's one of them.
Yeah.
I don't know why I say that anymore. Like it's one of those days. No, it's normal.
Unless you're used to the phone doing spell check.
Right?
Mm.
There used to be a spelling monster growing up. They're like, certain stuff, I'm just like, is that right?
I know. It's so bad.
I will always question Wednesday and how it's spelled.
Wednesday.
Wednesday.
Yes. Okay, so these are our absolute basics. These are just our operations, the things that we see. So let's use an example of some of the next things that we might see. We need to talk about like terms. Like terms. Yes. So Like like terms.
Oh, boy.
So like terms are numbers with the same variable and the same exponent attached. So I'm going to write that little definition out. So numbers with the same variable and exponent. For example, let's look at 3x and 2x. 3x and 2x. Are these like terms?
Yes.
Yes, they are, because they both have x and there is no exponent, which means they have the same exponent. So, like terms can be combined by adding.
Have those in our problem we just had.
Yeah.
Question.
Uh-huh.
If one of your variables is negative and one is positive, then they're not like terms.
Do you mean like if it was negative 3x
Yeah.
and
Plus
2x?
positive 2x.
Okay, so good question. We are not worried about the base numbers being the same. They can be different. What has to be the same is the variable, meaning the letter, like x. So they have to all have x.
Okay.
So if I had like negative 3 plus 2x and there was no x on the negative 3, I could not combine that. But since these do have the same variable, they both have x,
Okay.
we can add them. And what do we get when we add these? We just get 5x. We're just adding the numbers. Just add the numbers. So I'm going to say these are like terms. But let me give you that example of not like terms. So if I had, like we said, negative 3, let's say plus 4x.
They're not.
These are not like terms. Why not?
Because the 4 has an X and the 3's by itself.
Yes, the 4 has an x. There is no x on the 3, so I cannot put these together.
Oh, just like it.
Okay, so what we're going to say here is no x on the negative 3. These are not like terms. Now, we have a couple of different ways that we can combine like terms in an equation. Sometimes we have like terms of variables on the same side of the equal sign.
Mhm.
So I'm gonna pull out let's do a sticky note here. Same side equal sign. Same side of the equal sign. And then I'm going to give you an equation that looks like this. Let's do 3x 2 plus 2 equals 12.
You combine like terms.
Yes. Whenever I have an equation where my like terms, the 3x and the 2x, are on the same side of the equal sign, we combine them by just adding them together. We combine them by just adding them together. So whenever I add these together, it's just like this problem here. 3x plus 2x is
5x.
5x. Then everything would come down, right? So on the same side, we combine by just adding together. So I'm going to say combine like normal. Where it gets different is when they're on a different side of the equal sign. When they're on a different side, we have to do something different. So the example I'll give you for this would be, I'll do 3x minus 2 equals 2x plus 1, for example. When our like terms are not on the same side, what do we have to do different?
Get rid of one of them.
We have to get rid of one of them by doing what?
Subtracting one.
Subtracting. So when they're on the same side, we can just add them. When they're on opposite sides, we have to do the opposite thing. That's when we use our inverse operations. That's whenever we subtract. So I'm going to say combine by canceling one, basically. Subtracting. Unless, of course, this is a negative. Then we would do the opposite of that and add. So, what would I do here?
You could subtract either or.
You could subtract either or. Which one do you think would make this problem easier?
Subtracting a two.
Yes.
Smaller.
Subtract, use the smaller one. The smaller one is easier because then you won't get a negative. I'm going to say subtract the smaller one. Or cancel the smaller one. So we would subtract 2x from both sides. And that cancels the 2x. And that would give us 3x minus 2x is
1x.
1x.
-2.
You could bring down -2 equals just the 1 is left over there. And we don't have to finish that one out for the sake of running out of space. But whenever you have like terms, this is one of the mistakes I've seen quite a few times is remembering if it's on the same side, you just add them like normal. Different side, we're doing the opposite. We'll do a different thing. We cancel one and combine it with the other. Okay.
It's a review.
Yeah, it's a
I
review.
was laying in my bed last night thinking about this. I was like, how come is she gonna do a review?
So there you go. Yes, and here it is. That's funny. That was funny.
Separated.
I was so laying in bed thinking about it.
Okay. So the only other real kind of major thing to remember is, well, we can take a little note of this. I'm going to scoop this up a little. Scoop this up a little. Is remembering that, and I mean, if this is something you struggle with, write it real big somewhere you won't forget. If I have an x by itself, this is the same thing as 1x, always. If I have negative x, what is that the same as?
-1.
Negative 1x. Always, 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 always. If there's no number next to x, the number is 1. If there's a negative but no number, the number is -1. So, this is what you can use to help you remember. Because that number just tells you how many x's there are. And if there's not a number, it's because you don't need a number to tell you. You can tell there's just one x I'm looking at. So, with all of this in mind, let's work through a crazy example together. I'm going to give you something nuts. Okay. Can I move this? Does anyone still need it? Okay. I'm going to give you a crazy example. And there will be a decimal answer, so that's okay.
That's my favorite one.
Yes. Okay. So let's do, and we're going to do this one nice and slow. Here's the problem. 2x plus 5, parenthesis, negative 5x minus 4 equals.
Oh.
Yep, it's an
I thought you were done.
equation. It's an equation. Just you wait. Negative 7, parenthesis, negative 2x plus 8. We can do it. I know we can. Just you wait. Minus 3. That's it. This is one equation.
Good.
And we're going to use all of the steps that we just reviewed and slowly, carefully go through solving this. Slowly and carefully. Okay. What do we need to try to do first? PEMDAS, parentheses. Let's try to get rid of these parentheses because if I have things in parentheses, I can't get rid of anything inside of them. I need to get the parentheses to go away. What does it mean when I got a number right outside of something? Yes. So I have two different distributions happening. I have 5 being distributed into this. I have negative 7 being distributed into that. So let's do those. Let's distribute. When I distribute my 5, what happens? I do get a negative number. So what am I multiplying?
5 times negative 5.
Okay, so 5 times negative 5x. Don't forget your x.
Yeah.
And what does that give us?
Negative 10x.
Negative, what's 5 times negative 5?
Negative 25.
Negative
Oh,
25.
yeah.
Ah. So negative 25x. I'm going to cross that out so I know I'm done with that. And then 5 times what?
-4.
Negative 4. And that is
-20.
negative 20. Okay, and now I've done both. I'm going to cross out the 5 too.
Okay.
Okay. Now what?
Bring everything down.
Bring everything down. Now, before I bring everything down, I'm thinking while I'm distributing one set,
Oh, yeah, you
let's
put
do
that a
both
sec.
just so
Oh,
that I don't have to
okay.
bring it down more than once.
Mhm.
So what am I multiplying here?
Yeah, negative 7 and negative 2x.
Okay, and what does that give me?
14x.
Good, positive 14x. And then what next?
Negative 7 times 8.
Good, negative 7 times 8 is
Negative 56.
negative 56. Okay, I'm done with all that. Look at all that we just crossed out. You only have 2 things to bring down now, right? Well, 3 if you count the equal sign. So I'm going to bring down my equal sign. What comes down?
Your 2x.
2x
And then your negative 3.
and my negative 3. Good, good. Okay, so now what do I do? Now that there's no more parentheses to get rid of.
Well, you can combine like term.
Okay, so we have some like terms. Let's see what all like terms we have.
You got 3.
And I'm going to underline them or circle them or something. What do I have?
2x.
2x,
Negative 25x.
negative 25x,
14x.
and 14x. 2x and negative 25x are on the same side. 14x is on a different side. What do we want to do first?
Work from left to right.
We can go left to right, absolutely. So what do I do whenever they're on the same side?
You subtract the negative 2.
Add them.
They're on the
No, you
same.
add 'em.
Ah,
Sorry.
yes. So remember, same side, we combined by just adding them. So 2x plus negative 25x.
When you add the 25 since it's in.
So we only do the opposite if it's on opposite sides. Right?
No, I'm talking about switching since it's negative 25, switch it to add 25.
So we're still,
Isn't that considered a minus sign?
this is like a minus sign. So we can either think of this as 2x minus 25x or 2x plus negative 25x. Does that make sense?
Well, give you the same answer if you do
It
it.
will give you the same answer. So if I'll show you both. I could do 2 plus negative 25 and I get negative 23. Or I can do 2 minus 25. I still get negative 23.
Oh.
Yeah. So either way will work. Either way will work. So if you are wanting to kind of write out to the side how you did that, I can say 2 plus negative 25 or 2 minus 25. Either way, we're still going to get negative 23.
Still bring the x.
Yes, we still bring down the x. So I'm going to bring down, when I combine those, I get negative 23x. And what should we do now?
Bring down your minus.
Negative.
Yeah, let's bring down minus 20. Bring down equals. I'm going to bring down 14x. I'll bring down minus 56. I'll bring down minus 3. And I'm going to draw that line before I get unorganized. And sometimes it really, like, there's a lot of things going on here, lots of numbers. if it helps, cross out everything from the previous step, just so you know, this is where I am. I'm not looking at anything above.
Now, can't you do the subtract the 14x on both sides of this?
Yes, you could do that. You absolutely could. I could try now. Let's combine the negative 23 and the 14. Since 14 is a positive, we would subtract it. You're right. So we'll do minus 14x on both sides. And let's see, now we're doing negative 23 minus 14.
Negative 36.
So negative 37. I think that's right. Yes, negative 37. So what do we bring down?
Negative 37x.
Good. Negative 37x
Minus 20
minus 20.
equals,
Mm-hmm.
then, the minus 56 minus 3.
Good. Minus 56 minus 3. Okay. Now, we have all of our x's together. But I've also got a bunch of numbers that don't have x's. Are those like terms too?
Yeah.
Yes, they're like terms with each other. My non-x's can be combined. Just like I combined the x's. So we have options. What's one thing I can do?
The smaller number? Yeah, I was gonna say.
Subtract the smaller number. What you mean?
Or actually, you could do the 20.
Do the 20.
Do the 20? Okay,
To get
so
the x by itself.
to get the x by itself, okay, so like, what am I doing with the 20?
You're gonna add it.
Yeah, let's add 20 to both sides. Now, does it matter where I add 20? What?
I said, could you combine the 56 and 3 first?
I would.
Because that's what I did.
I would. So we also see over here, I have negative 56 minus 3. These are just numbers. There's no variable that says I can't put them together. Let's put these together first.
Oh, okay.
So negative 56 minus 3
Negative 59.
is negative 59.
And then you can subtract this one.
Yeah, and then I'll do that plus 20 under the negative 59.
That's part of energy.
Yeah.
The deep.
Good.
I was over here scratching my scalp.
Okay, so now what?
Bring down your negative 37x.
Good. Those are going to cancel there. So negative 37x. Bring down my equal. And what happens here?
Take your the negative 59 and add to it.
Yes, negative 59 plus 20 is negative 39. Wow. And look, we're almost done. What's our last step? Divide by negative 37. And we will get a decimal. Yes, x equals 1.05. I'm just going to leave it at that. Perfect.
I'd rather do this.
Hey. Okay. We can do hard things.
Miss Taylor.
Yes.
So like we're on a test, right? Do we have to round it up or we can leave it?
If the number after 5 was another 5 or bigger, then we would round up. But since it's 4, we don't have to. Now, if you're asking, am I going to count it wrong if it should be round up and you don't, I'm not going to be picky on rounding. As long as, like, if you put 1.05, I'll take it. If you accidentally round it up and put 1.06, I'll take it. Close enough. I won't be picky. Any other questions? Hey, guys.
This type of question gonna be on the test.
No. I just wanted to give you something kind of crazy and show that even though it looks insane, it looks like there's so many steps. It really is not impossible. We can do it. We know how to do it. We just got to break it down into smaller steps and then we get our answer. But no, we're not going to be doing stuff like this on the quiz.
That's definitely one of them. Like,
Uh-huh. Okay. I feel like that was a good review today. Do you guys feel like that helped a little?
definitely.
Yeah.
Okay.
Helped a lot.
Good. Good. Okay. Well, I told you we would have a shorter class today because I know a few people still need to take that quiz. So if you have already taken your Unit 3 quiz, if you turned in your practice quiz, and you did the exit ticket from yesterday, if you don't know if you did, it's the day 23 exit ticket. I believe I put one in everyone's folder. If you did it, it should be graded back in your folder. It looks like this. If you didn't, if you have all of that done, you are free to go.
Kind of.
You may stay. You're free to go, but I'm not kicking you out. You're welcome to stay.
comments. No.
Yes. So that's it, you guys. I hope you have a wonderful weekend. And I'll see you on Monday.